Alright, so our last topic in this chapter 4 is our concept of inverse functions. So we're going to discuss what an inverse function is and how to find them. So an inverse function, an inverse relation or an inverse function, is a set of ordered pairs obtained by exchanging the x-coordinates with the y-coordinates for each ordered pair in the relation. So if 3, 5 is in your relation, if I swap those and make it 5, 3, this is now an inverse relation. All we're doing is just swapping x and y's. So if I want to find the inverse of this relation right here, well, it's inverse. We're going to swap our x and y, so it's negative 10, 4, negative 19, 7, 17, negative 5, and 11, negative 3. Now I represent the inverse of this relation right here of ordered pairs. And we're going to use this concept of swapping x and y's to find the inverse function given a linear normal function. So what we're going to do is we're going to, linear relation is described as a function as an inverse function, so that's what's generating ordered pairs of the inverse relation. So we're going to write our inverse as this right here, f essentially to the negative 1 of x. That's our inverse function of f of x. And it's a 4-step process to finding this inverse function. First thing you want to do is, if it's f of x, then you need to replace f of x with y. If it's just y, you don't need to worry about step 1, but you need to replace your f of x with y. You're then going to interchange your y and x values in the equation. You're going to switch them. So wherever you had a y, you put an x. Wherever you see a y, you put a, wherever you see an x, you put a y. And then you're going to solve this new equation for y. Once you have y all by itself, you're going to rewrite that as f to the negative 1 of x, your inverse function notation, and you have your answer. So let's try that. So f of x equals 4x minus 8. And I want to write this as its inverse function. So I'm going to replace f of x with y. So y equals 4x minus 8. And now I'm going to switch my x and y values. This becomes x equals 4y minus 8. Now I want to solve for y. So I have to add 8 to both sides. The x and the 8 cannot combine, so it's x plus 8 equals 4y. I then divide both sides by 4. And you get 1/4 x plus 2 equals y. And now the y is all by itself. That tells you my inverse function is 1/4 of x plus 2. And that's all you need to do. You're just going to be swapping x and y's and then solving for your new y equation. So f of x equals negative 1/2 of x plus 11. So again, I want to rewrite f of x as y. Swap the y and the x. And now solve for y. So I subtract 11 from both sides. X minus 11 equals a negative 1/2 of y. And then to get rid of the negative 1/2, multiply everything by a negative 2. So negative 2x plus 22 equals y, which tells you my inverse function is negative 2x plus 22. Pretty straightforward. So I want you to do this on your own. Again, you want to rewrite f of x as y equals 3 times x minus 6. And then go ahead and swap your x and y and solve for your new y expression. So I'm going to pause the video while you work that out. Alright, so you should be getting your inverse function to be 1/3 of x plus 6. Because again, I would make this x equals 3 times y minus 6. I distribute my 3, 3y minus 18. I add my 18 to both sides. I divide by 3. 1/3 of x plus 6 is y. And that's why that's my inverse function. So there is no f of x notation, but the concept still remains the same. You're going to swap, you're going to interchange your x and y values, and then solve for your new y. So again, pause the video while you work that one out. And you should be finding that your inverse function for this will be 7/2 of x minus 14. Again, you would start by rewriting as negative 7x plus 2y equals negative 28. and then rearranging to solve for y. So that's how you write inverse functions. Very straightforward process. Alright, our next videos will be starting in Chapter 5, dealing with linear inequalities. So I will see you next time.